Welcome to the Deep Dive. Today, we're diving headfirst into AI agents. Now, you're probably familiar with large language models, LLMs, right?
Hmm.
And how they use context to answer questions, sort of like the RAG systems we've talked about before.
Right.
But AI agents, they seem to take that intelligence and, well, give it the power to act.
Exactly. That's the key difference. Think of it like this. A RAG system, it's like a super smart librarian, finds you the info you need.
Okay.
An AI agent, though, is more like a personal assistant. It doesn't just find the information, it uses it to get tasks done for you.
Okay, so give me an example.
Well, take insurance. A RAG system could explain your policy coverage for, say, water damage,
Hmm.
but an AI agent, it could take your claim, actually analyze the documents, compare it against the policy details, figure out the payment amount.
And even start the payment process.
Potentially, yes.
Yeah.
It's really the difference between knowing and doing.
Okay, let's unpack this then. We're talking about software powered by these LLMs
Right.
that can autonomously make decisions, take actions, coordinate steps, all to reach some goal.
That's the core idea, autonomy and action towards a goal.
And this isn't just theory, is it? I saw some research from Capgemini.
Oh,
Something like 10% of organizations are already using them.
that's right, 10% now. But the really striking figures are the projections.
Yeah, tell me about those.
Over half, more than 50%, plan to adopt AI agents in 2025.
Wow.
And it jumps to 82% expecting to use them within the next 3 years. The momentum is, well, it's significant.
That's incredible speed. It really signals how transformative people think this tech is.
Absolutely. It's not just potential anymore. Organizations are actively moving towards it.
Okay, so for this deep dive, our mission basically is to get to grips with the fundamentals of these AI agents.
Exactly.
We're using a resource, Mastering AI Agents, as our guide. So think of this as, your fast track to understanding this really important technology.
And we won't just define them. We want to clarify, when they're the best tool for the job. And crucially, when maybe they aren't the right fit.
Okay.
We'll look at some real-world examples, too, and then dig into the main frameworks for actually building them. Things like LangGraph, AutoGen, Crew AI.
So practical insights on choosing the right tools as well. Fantastic.
That's the plan.
All right, let's plunge in. We know what they do generally, but what kinds of AI agents are actually out there? Are there different flavors?
Yes, definitely. The book, Mastering AI Agents, lays out a really helpful classification in its first chapter. It breaks them down based on their characteristics and what they're best used for.
Okay, lay it on us. What are the main types?
Well, starting at the most basic level, you have fixed automation agents.
Fixed automation, like a digital assembly line?
Pretty much. No real intelligence there, just following preset rules for repetitive stuff. Think RPA, robotic process automation, or basic email autoresponders.
Gotcha. Good for simple, repetitive tasks with structured data. No thinking involved.
Exactly. They're the assembly line worker. Efficient, but not adaptable.
Okay, what's the next step up in smarts?
Next are the LLM Enhanced Agents. These are smarter because they use LLMs to understand context.
Okay.
But crucially, they still operate within defined rules, and they're usually stateless. They don't remember past chats.
Stateless, so no memory.
Generally, yes.
Yeah.
Think of smarter email filters, maybe content moderation tools, or routing customer support tickets intelligently.
So they understand more, but they're still following a strict playbook.
Precisely. Like a helpful assistant who gets the gist but has to stick to the rules.
Yeah.
Good when you need some flexibility, but it's low risk.
Okay, makes sense. It sounds like things get more dynamic after this.
They do. Next up is React. That's short for reasoning meets action.
React, reasoning and action.
Okay. These agents can handle multi-step workflows. They can plan dynamically, break down complex tasks, and adjust their approach based on new information.
So they can think, then act, and sort of change the plan on the fly.
Exactly. Think of a travel planning agent putting together a whole itinerary, or maybe an AI game master in a role-playing game that adapts to what the players do.
Like that super organized friend who plans every detail of a trip meticulously.
Kind of, yeah. They're great when the path isn't straightforward. More like how humans problem solve. Try something, see how it goes, adjust.
Interesting. So what happens if you give these React agents access to, say, external information?
Well, that leads us nicely to the next type. React plus RAG. The source calls it grounded intelligence.
Grounded intelligence, okay.
So you take the reasoning and action of React and you add retrieval augmented generation array. This lets them pull in external knowledge.
And the big benefit there is less making stuff up. Fewer hallucinations.
Exactly. It grounds their responses in real data. This makes them ideal where accuracy is absolutely critical. Think legal research tools or medical assistants referencing actual studies.
Right, like a trivia expert who also has Google on speed dial.
That's a good analogy. They know things, but they can also look things up instantly and reliably.
Incredibly valuable for certain fields. Okay, what else is in the taxonomy?
Then we have the tool-enhanced agents. These are the multitaskers, the Swiss Army knives.
Tool enhanced, so they use other software.
Yes, they can integrate with all sorts of external tools, APIs, databases, other software. They can reason, find information, and then use a specific tool to execute an action.
Examples.
Maybe a code generation tool that pulls in different libraries, or a data analysis bot that connects to multiple data sources through APIs to get its job done.
A real automation powerhouse, then. Very versatile.
Very. Now, things get a bit more introspective with the next type. Self-reflecting agents. These are the philosophers, you could say.
Philosophers? How so?
They have metacognition. They can essentially think about their own thinking process. They can analyze their reasoning, evaluate if they made a good decision, learn from mistakes, and even explain why they did something.
So they can explain themselves. That sounds huge for trust and debugging.
Absolutely. Great for things like quality assurance or in situations where you really need to understand the why behind an AI's decision, like an agent that not only gives an answer but tells you how it got there and flags potential weaknesses in its logic.
Fascinating. An AI that critiques itself. Okay, what about memory? You mentioned stateless earlier.
Right. That brings us to memory-enhanced agents, the personalized powerhouses.
Okay, I like the sound of that.
These agents have long-term memory. They can store and recall past interactions, user preferences, maybe project histories.
So they learn about you over time.
Exactly. This allows for much more tailored, personalized experiences. Think of a really good virtual assistant that remembers what you liked last time, or a project management AI that knows the history of the project.
A true digital companion, almost. Okay, now you also mentioned agents interacting with the world around them.
Yes. Environment controllers. These go beyond just processing information. They actively manipulate their surroundings.
Manipulate, like physical surrounding.
Could be physical, could be digital. Think autonomous robots in a warehouse managing inventory, or smart city systems adjusting traffic lights based on real-time conditions.
So they sense, reason, act on the environment, and get feedback. Like a smart thermostat, but for, well, anything.
That's a great way to put it. A smart thermostat on steroids, controlling complex systems.
Feels like we're getting closer to fully autonomous systems here. What's the final category?
The final type is self-learning agents, the evolutionaries.
Evolutionaries, meaning they evolve on their own.
Pretty much. They can autonomously learn, adapt, and improve without constant human hand-holding. They refine their own models based on feedback, new data, changes they observe.
Examples.
Think neural networks using reinforcement learning, or maybe swarm AI systems where agents learn collectively. They're like AI researchers constantly running experiments on themselves to get smarter.
Wow, okay. That's quite a spectrum of capabilities, from simple automation right up to self-learning.
It really is. And the key takeaway is there's no single best type. It's all about matching the agent's capabilities to the specific problem you're trying to solve.
Right. Which leads perfectly to the next big question.
Yeah.
With all these options, when should you actually use an AI agent?
That's a critical point. The source really emphasizes that agents deliver the most value for tasks needing complex decision-making, a significant degree of autonomy, and the ability to adapt to changing situations. They excel in dynamic, multi-step environments where intelligent automation can really make a difference.
So not for simple static tasks.
Generally, no. Chapter 1 actually has a helpful table, 1.1 showing good examples across different sectors.
All right, give some concrete examples. Where are agents making a real impact?
Well, customer support is a big one.
How so?
Agents can handle huge volumes of queries, offer instant help 247, and even smartly escalate the really tricky issues to human agents, providing all the context.
So faster responses, happier customers, and human staff freed up for complex problems.
Exactly. Then there's research and data analysis.
Wading through data.
Right. Agents can autonomously gather info from all over, process massive data sets, find patterns, things that would take humans ages or might be missed entirely.
I can see the productivity boost there. What else?
Financial trading. Agents can process real-time market data and execute trades based on complex algorithms much faster than humans.
Speed is key there.
Definitely. In education, agents can create personalized learning paths, adapting to each student's pace and needs.
Tailored education, interesting.
And software development agents helping with writing code, finding bugs, running tests, streamlining the whole process.
So it really boils down to complexity, the need for speed, autonomy, adaptability.
That's a good summary, yes.
Okay, so on the flip side, when might AI agents be overkill or just the wrong tool?
That's just as important to know. The source points out that for really straightforward, simple tasks that don't happen very often or only need minimal automation, well, an agent might be more trouble than it's worth.
Right. Don't use a sledgehammer to crack a nut. If the current way works fine, why complicate it?
Exactly. And then there are tasks that really need deep, specialized human expertise.
Like what?
Things requiring nuanced human intuition or genuine emotional empathy, complex legal arguments that depend on understanding intent and precedent, intricate medical diagnoses needing a doctor's holistic judgment, or, say, psychotherapy, which relies heavily on human connection.
The irreplaceable human touch, basically. Anything else?
Well, practical things, too. Building and maintaining these agent systems isn't trivial. It takes time, money, specialized skills. For some organizations, the cost might just not stack up against the benefits.
Good point. And regulations.
Yes, especially in highly regulated industries like finance or healthcare. Compliance and security rules might limit how you can use agents or add significant overhead to ensure you're meeting requirements.
So definitely not a magic bullet for everything. You need to think carefully. The source actually gives 10 questions to ask before jumping in.
Yes, a very useful framework for evaluating if an agent makes sense for a specific task.
What are some of the key ones?
Okay, first, how complex is the task, really? Does it need autonomous decisions, or is it rule-based?
Right.
Then, what's the expected volume? Lots of data, lots of queries. Agents handle scale well.
What about learning? Is that important?
Yes. Does the task have potential for the agent to learn and improve over time? That's a big plus. Also, how frequent is the task? Daily, hourly, or once a year?
Okay, adaptability.
Crucial. How much does the agent need to adapt to changing conditions? And what's the required level of accuracy? Is it nice to have or mission critical, like in medicine or finance?
Accuracy is huge. And the human element again.
Yes, does it need that deep human expertise or emotional intelligence? Are there strict regulatory or compliance hurdles? What about privacy and security?
And the bottom line.
The cost-benefit analysis. Does the ROI actually justify the investment? Asking these questions up front can save a lot of headaches later.
That's a really solid checklist.
Yeah.
Okay, to make this even more concrete, the source shares 3 real-world examples. Let's hear about those.
Right. These really show the tangible benefits. First up is Wiley, the education publisher, using Salesforce's Agentforce.
Wiley. Okay,
Yeah.
What was their challenge?
Big spikes in customer service calls right at the start of every semester. Predictable chaos, as you said earlier.
I can imagine. So how did the agent help?
Agentforce, the AI customer service agent, basically helped them handle that peak load much more effectively. Faster resolutions.
And the results.
Pretty impressive. Over 40% increase in case resolution compared to their old chatbot. A 213% ROI overall, and cost savings around $230,000.
Wow, that's significant. A clear win for customer service automation. What's the next case?
Oracle Health and their clinical AI agent. The problem here is a common one in healthcare. Doctors spending too much time on documentation, leading to burnout.
Yeah, that's a huge issue. Less time with patients.
Exactly. So this AI agent helps automate documentation using a voice interface. Doctors can get patient info quickly, generate notes more easily during or after visits.
And did it work?
One healthcare network, Atlanticare, reported a 41% cut in documentation time. That saved doctors about 66 minutes per day.
66 minutes a day. That's huge. More time for actual patient care.
Precisely. It enhances that crucial patient-provider interaction.
Fantastic result. Okay, what's the third example?
The last one involves Majid, a company providing consumer insights to media brands. Their challenge was ensuring consistent, high-quality content in the super fast-paced news world.
Oh, maintaining accuracy and brand voice when everything moves so quickly. Tough job.
Right. They integrated Galileo's AI, specifically its real-time observability features, into their content workflow.
Observability, meaning?
They could continuously monitor their content outputs, track metrics for things like tone and accuracy, and customize content delivery at scale.
And then payoff.
They got 100% visibility over their AI-driven content processes, This let them spot trends, create client-specific metrics, and ultimately improve the accuracy and quality of what they delivered. It's about empowering newsrooms while keeping standards high.
Three really different examples: customer service, healthcare documentation, content quality, all showing real, measurable benefits.
Exactly. Greater productivity, faster resolutions, quicker task completion. The impact is clear.
Okay, so let's say someone listening is inspired by this and wants to build their own agent. What tools are out there? What are the main frameworks?
Good question. Chapter 2 of the source dives into 3 prominent frameworks that really help build these agentic applications: LangGraph, AutoGen, and Crew AI.
LangGraph, AutoGen, Crew AI. Got it. Let's take them one by one. What's the deal with LangGraph?
LangGraph comes from the LangChain folks. It's open source, designed for building stateful multi-actor applications using LLMs. The core idea is representing workflows as graphs, specifically directed acyclic graphs, or D's graphs.
It's RAFs, like flowcharts for AI actions.
Kind of, yeah. It gives you really fine-grained control over the flow and state. It's great for complex workflows where you need solid memory management, ways to handle errors gracefully, maybe even points where a human steps in.
Human in the loop. Okay.
And because it's from LangChain, it plugs right into their whole ecosystem of tools and models.
So if you've got a really complicated process, lots of steps, potential branches, need robust error handling, LangGraph sounds like a good bet.
It's definitely a strong contender for that kind of complexity, yes. It provides that structure.
Okay. What about AutoGen? How does that differ?
AutoGen comes from Microsoft. It takes a more conversational approach.
Conversational.
Yeah, it frames workflows as dialogues between multiple AI agents. If you're used to things like ChatGPT, it can feel quite intuitive. You build AI collaborations that work kind of like humans chatting to solve a problem.
Interesting. So agents talking to each other.
Exactly. It supports tools like code executors and function callers, so agents can do things based on these conversations. It's designed to be modular, customizable, adaptable.
So if you're thinking about your agents as a team that needs to communicate and collaborate through discussion, AutoGen sounds like a natural fit.
It can be, yes. That conversational paradigm is its strength.
All right. And the third one, Crew AI. The name suggests teamwork.
It does. Crew AI is specifically built for managing collaboration between role-based AI agents.
Role-based.
Yeah. You define specific roles for each agent, like researcher, writer, editor, and give them specific goals. They then work together as a unit, a crew, to achieve a bigger objective.
Ah, okay. Like building a virtual project team.
Exactly. It's really good for sophisticated multi-agent systems like that. It handles task management well, lets agents delegate tasks to each other autonomously, and you can plug in custom tools for specific roles.
So if your project involves assembling a team of specialized AI agents with distinct jobs working towards a common goal, Crew AI sounds ideal.
It's definitely designed for that kind of setup.
Okay, 3 frameworks, 3 different approaches. When you're choosing, what are the practical things to weigh up? The source compares them, right?
It does, across several key factors. Things like ease of use, obviously. How easy is it to get started?
Always important. Who has the edge there?
Generally, AutoGen and Crew AI are seen as a bit more user-friendly initially. AutoGen's chat-like flow and Crew AI's clear role structure can be easier to grasp than LangGraph's graph approach, especially if you're new to it.
Okay. What are the tools they can use? Integration seems key.
Right. LangGraph and Crew AI benefit hugely from being tied into the LangChain ecosystem that gives them access to a massive library of existing tools and integrations.
And AutoGen?
AutoGen also supports various tools, including built-in code execution, and its design makes it fairly easy to add new ones. But LangGraph and Crew AI probably have the edge on sheer breadth out of the box via LangChain.
Makes sense. What about remembering things? Context maintenance.
Crucial for coherent conversations or workflows. LangGraph and Crew AI both have pretty sophisticated memory features, short-term, long-term entity memory, so they can track context well across complex interactions. AutoGen manages context well with its conversational flow, too.
Okay. The source also looks at other things, right? Like structured output, documentation, quality.
Yes, structured output getting predictable results. Documentation all are pretty good. Maybe LangGraph and Crew AI have more examples. Multi-agent support LangGraph's visual graph can be helpful there.
What about caching for speed or replaying interactions for debugging?
All support caching. Replay is generally straightforward in LangGraph and Crew AI. Code execution AutoGen has it built in nicely, but all can do it. Human in the loop all support it in different ways.
Customization, scalability. Open source models?
All are customizable. Scalability is maybe less clear-cut, probably needs testing for your specific case. And yes, all support open source LLMs.
So it really sounds like the choice depends heavily on your specific project needs and maybe your preferred way of thinking about the workflow.
That's exactly it. To summarize crudely, LangGraph for complex graph-based workflows where control is key. AutoGen for conversational collaborative agent flows. Crew AI for building role-based teams of agents.
That's a helpful shorthand. Do we have examples of companies using these specific frameworks?
We do. For LangGraph, the source mentions Chaos Labs. They built an AI system for prediction markets, using LangGraph to manage a multi-agent council to ensure accurate, unbiased results.
Interesting. Using agents for consensus.
For AutoGen, there's OptiGuide. They use it to optimize supply chain decisions, analyzing supplier choices within Microsoft's cloud, focusing heavily on data privacy.
Supply chain optimization.
Okay. And for Crew AI, Waynabox. They're a travel company using Crew AI to build multi-agent systems that create personalized travel itineraries automatically based on user preferences and real-time data.
Personalized travel planning. Very cool.
These examples really show the frameworks in action, reducing manual work, making operations smoother, improving productivity in very different domains.
It really drives home that core promise of AI agents we talked about earlier.
Absolutely. And while the frameworks help immensely, the source also stresses, the importance of properly evaluating and testing these agent systems for accuracy, reliability, that whole performance piece.
Which is critical. Well, this has been incredibly thorough, a real deep dive into AI agents.
We covered a lot of ground.
Yeah, from the different types, when to use them, when maybe not to, those real-world examples, and then the frameworks like LangGraph, AutoGen, and Crew AI.
And the main takeaway, I think, is that agents are a really powerful step beyond just information retrieval LLMs. They offer autonomous action.
Right.
But success hinges on making smart choices, the right agent type, the right framework, all based on carefully analyzing the task and what you want to achieve.
And for you listening, our learner, we really hope this gave you a solid, structured overview without being too overwhelming. The goal was to hit the key points, share some maybe surprising facts, and show practical applications to, get you thinking.
Exactly. So as you mull over everything we've discussed, the rapid progress, the capabilities, maybe think about this. What new possibilities or perhaps challenges do these autonomous agents bring to your field? What does this shift from just getting information to enabling autonomous action really mean?
That's a great thought to leave people with. It's a fascinating area, evolving incredibly quickly.
It certainly is.
Definitely encourage everyone to keep exploring. Thanks so much for joining us for this deep dive.